Hello, in this video, I'm going to be taking you through my process for creating naturalistic grass using PCG inside Unreal Engine. I'm going to cover not just how to set up the nodes, but how to create parameters inside your PCG graphs so that you can go ahead and reuse this graph over and over again every time you need to make grass in your projects. I'm also going to be covering the best settings for creating efficient spawning, and so that you can create a lot of grass very densely over your whole entire landscape, whether you have a really large open world game or you're just trying to get your viewport to run more smoothly. I will cover the best settings for that. We got a lot to cover, so let's get into it. So I'm going to start here with this landscape, and we'll start by creating our first PCG graph here. We'll also right click in the empty space and come to PCG and choose PCG graph, and we'll call this PCG underscore grass. And I guess I'll call this version 1. And if you don't see this as an option, it means you need to enable PCG as a plugin, which you can come and do by hitting the edit button and plugins and typing in PCG. And we need to just make sure we enable this procedural content generation framework 1 right here. So once we made our PCG graph, we can go ahead and drag it into our level, and we'll keep it small right now as we're working, and then we'll expand it later when we've added in the optimization that we need to do to have it be able to expand comfortably over our entire landscape. And I'll come over to the right side here and with the graph selected and just hit generate, just in case sometimes it doesn't start generating automatically by default. So we'll double click on that graph to open it, and I'm going to go ahead and expand it here so we can see it in the top. Okay, so the first node that we need to make is getting our landscape data. So we're going to go ahead and right click here and type in landscape and choose a get landscape data node. This is going to sample whatever landscapes we have in our level already set up. If you're using a mesh, you'll need to use a get mesh data node, but in this case we're using a landscape. So I'll go ahead and drag off of this, and next we want to use a surface sampler because we need to make sure that we're sampling points along that landscape, not just getting the data from it, but actually sampling the points there. So we'll go ahead and create that next. And if I go ahead and press D to debug, we can see the points that we're getting out of that node. Now, the cool thing about this approach to Grass that I'm going to be covering is that we don't actually need this many points even. We need a very sparse amount of points because we're going to be taking those points as the first grass seed and expanding it from there. So this is too many points for us actually. And so we can come over here to the points per square meter and drop it down to 0.01. So that's a lot fewer points, and that will be a good place to start for our grass. So the way that this process will work is we'll take this first set of points, and then we're going to create a little grid of points around that, going to represent how in nature, when you have one plant, it will send off seeds, and those seeds will go ahead and plant additional ones, which will send off seeds. And that is why grass and other plants, when they're in nature, will have this natural kind of clumping look where you have the older or bigger plants in the middle, and you'll have kind of smaller ones, and they slowly blend out. If you ever wondered why that is, it's because of this sort of natural way that these plants expand through their environment. So by mimicking this in our PCG setup, we can get a lot more natural looking grass. So this will be our first seed point. Next, we'll create the points that it sends out. So we'll go ahead and create a grid, create points grid here. And this is going to create, like it says, a grid of points. And over here in the settings, I will keep the grid extent here 500 by 500, which is depth and width, but I don't really need any height to the grid. I just need one sort of single plate of points. And so I can go ahead and drop this Z value, which is the height of the grid, down to 1. So I'll go ahead and type in copy points, and the target is going to be plugged into the surface sampler here, and the source is going to get plugged into the create points grid node. And I will stop debugging the surface sampler. I'll press D, and we'll go ahead and debug the copy points node. And you can see here that it creates these white grids, which are actually made up of little points, and they're positioning them at each starting point that we've already set up. So in order for us to see what we're doing a little bit better with these points here, I want to go ahead and add a noise to it, which we'll use later on actually to thin out the points if we need, but I'll create a density noise node. So I'll drag off of here and type in density, and we'll go and choose a density noise here, which is actually just an attribute noise, but it automatically adds this density input here for you. The output is source. So I'll go ahead and stop debugging the copy points and look at this one. We can see now it's added a random black and white or random value between black and white, which is what density is, to each of these points. So now we can see them a little better and do things with that density. Now let's go ahead and start adding some randomness, because it's not going to really look natural and correct if we just have a grid. So we can add a transform points node to add some randomness to these. So I'll drag off of here and create a transform points node, and on the right side here we'll add a random rotation here. I'll type in 360. Let's go ahead and undebug attribute and debug transform points. And we can see here that it's added a random rotation between 0, which is this first number. We're talking about rotation min and rotation max. So it's 0 and 360 in the Z axes, which is the up and down axes. Now that we've added this random rotation in that axis, we also need to add random position, because we need to break up this cube looking shape that the points are making. So I'll come over to the offset min and max here. Let's see how much we need to add actually in these axes to make it look random enough. So I can try negative 100 as the minimum and positive 100 as the maximum. And remember, we don't want to add it to the Z position. We want them to stay in line with the ground. So we'll do negative 100 in X and Y. And that looks pretty good, but I think it could look a little more random. I still am getting this kind of grid look to the points. So I will up it to 100 in maximum and negative 200 in minimum. And you can see it kind of moving around up there as it rearranges. Okay, those are looking a lot more spherical in shape, and that's kind of what we want. We want this round looking clumping around those original points that we set up. Okay, so I'm going to go ahead and make a density filter here, and we're not going to use this quite yet, but if you can take a look at it here, what it's doing, it's taking the density values that we put in the attribute noise, and it's just cutting them down a little bit. So we can see here I have all the points, and if I lower the upper bound down, it'll start cutting out those points. And we're going to use that later as a parameter to adjust our graph outside of it to kind of control the density of our grass. But by default, just keep it at the lower bound as 0 and the upper bound as 1, which will let all the points through, because we haven't set that up yet. So just make sure that those are between 0 and 1, and we'll move on and we'll come back to this node in the future. So next, after density filter here, we have points growing out from the center, which is good, but what would be better is we need a way to show that the grass that's further away from that center point is younger grass. So in our case, just smaller. And then the points in the closer to the middle where that parent grass came from was planted first is going to be bigger. And this will start to add that natural look that makes this grass look better than just randomly scattering it over our entire landscape. So we'll go ahead and create a distance node. And the one that we want here is the spatial distance version. There's 2 distance nodes. The other one looks like this under attribute vector ops, and this is what it looks like. This is not, we want this one that we see under the spatial option. So we'll choose that and come here. And the target here is going to be that first point that we spawned. So these are the points that we're measuring against, and we're measuring against these first points that I spawned in the beginning. And I could go ahead and drag off of this and connect it up, but I think there's a way that's a little bit more organized that we're going to use here, and that is to create a reroute node. And so I will go ahead and type in reroute, and I want to create add named reroute declaration node. This will create this node, which basically just takes this point in the graph, and then I can access it later somewhere else. So I'll go ahead and hold down Alt and click here to disconnect that pipe and plug that in here, and we'll move that out. It doesn't actually do anything as a node besides declaring this reroute, so you can just put it in between here, in between these nodes. Okay, so next we will go ahead and get that we've declared over here. So it's because it's rerouting. It's basically an invisible line going from this node to this one that we're about to create. So we just need to look at the name here of this named reroute node and type it in ourselves here. So I'll type in surface, and we can see this named reroute nodes. Under this here, we should see surface sampler out. This can go ahead and plug into target. And this is exactly the same as plugging the line straight all the way over here. And this is not a huge graph. It's not going to be a huge graph, but especially as your graphs get bigger, this is invaluable in terms of keeping them organized. Okay, Now I have my distance from the original point and my points moving out, and I'm measuring that. So let's go ahead and debug that node and see how it looks. Something to remember to do is once I've made this distance node, I need to come over here to the set density and check that on. That will set the actual density values of those points with the distance instead of just storing it in a distance variable. So this is now showing us a kind of a dark gray color, and that's because the maximum distance is something here that we just need to drop down till it's in the range that we want it to measure against our points. So we'll drop that down to something like 1,000 or maybe 700, and you'll need to kind of adjust this till you get a nice gradient in your points, because this is what we're going to be used to set the scale, which is what we'll do next. So we'll go ahead, drag off of here and create an execute blueprint. And this one will give us access to a very helpful node called scale by density. And this will take the density value and scale the points based on it. So super useful node. Right now it is using a scale of min 0 and max 0, which is going to take all the points and drop them down to 0. So I need to go ahead and add either a 1 in max and a 0 in min. But if I do that, you'll see, if we go ahead and look at that, it's doing the opposite of what we want. It's creating the points in the middle as 0, and the points on the outside, they get bigger. So we'll just flip that. And so we'll flip these numbers. We'll put the scale min as 1 and the scale max as, we'll make it maybe 0.2 or maybe 0.5. Don't want it to be too crazy. We just want a slightly smaller grass size on these outer rims. Another thing we want to do here is, you can see there's this really large area of black, and that's because measuring the point's distance based on the bounds of that original point. So if we come back over to our first surface sampler here and we drop the point's extents down to 1, you can see we're getting a little bit nicer of a gradual blend out from the center to the outside, because those points are big, so they're kind of taking over the first few bunch of points in the middle, and they're coming out black, so they're not really measuring from the like a single point in the middle. It's the bounds of those original points. So if we shrink those bounds down from those big points that they were down to smaller points, if we look at them right now, what they look like, they're actually too small to see. They're really tiny here, but that's fine for us. But what we really wanted to do is just make sure that those bounds are not messing with our distance calculation. So that's good, even though they're too tiny to see. We'll just leave it like that. We'll come back to our scale by density. We have to do one last thing here, which is to project these points back down onto the landscape. We know that our landscape is flat right here, so our points are working pretty well, but if we were to move our points over to the more hilly areas of the landscape, they would stop really melding with the surface. They would kind of have these flat, they would kind of be sticking out, they would be just flat, they wouldn't be blending with the surface. So we need to project those points back down on the landscape, because the grid here we made is just a flat grid. It's not really sampling the surface. So now that we have our set of points that we're solid on, that we're using, we can go ahead and create a projection node, and the target is going to be our landscape here, but we will go ahead and make another reroute node so that we don't have to pull it all the way over here. I'll come and I'll drag off of this get landscape data node, and we'll create a named reroute, and we'll put it in between here. And then I'll come back over here to the projection, and we'll type in landscape, and we'll get this landscape data out under the named reroute, and we'll plug it into projection target here. And we won't see too much change, but you can rest assured that they're now getting projected directly down onto our landscape, which is what we want. If you're getting a lot out of this video and you've gotten a lot out of my other videos, you might be interested in something that I recently launched called Aial Art Academy. It's for those of you who are tired of sifting through YouTube videos to try to piece together all the information you need to get good at environment art with Unreal Engine. It basically takes all my courses and combines it with coaching and a private group where you can get all of your questions answered. If this seems like something that you might be interested in and you're looking for more personal attention and support in your Unreal Engine journey, this might be something for you. If you're interested, check out the link in the description below this video. Let's get back to the tutorial. Next is to put some meshes in here and see how it's looking. So I'll right click and make a static mesh spawner, and we'll plug it in here. And this is where our optimization starts. So we'll add our first mesh, and then we're going to do a few things here that will start to optimize this graph so we can get a lot denser grass down the road. So we'll go ahead and hit this plus button under mesh entries, and we'll expand the index here, and we'll come over to the descriptor in the static mesh input. We'll go ahead, I have some grass saved here. So we'll go ahead and drag this grass in here. And the settings that we want to change here for the grass are coming over here to the collision presets, and we're going to switch that to no collision. And that will cut down the calculation time of our graph quite a bit. You don't really need collision on most things you spawn in PCG. They're often plants and stuff like that, and adding collision onto them is actually going to mess you up later because your character will weirdly be walking on top of them. We don't want that anyway. So turning off collision will both save you a lot of compute time and, you know, make it more efficient for you play wise down the road. So that's good. And we want to also turn off generate overlap events, and that will help this spawn as smoothly and efficiently as possible. So if we come over here and I stop debugging our projection node by pressing D, we can see we're getting some great naturalistic looking grass spawning. You can see that the grass is bigger in the center and smaller as it goes out. We could even make that a little more obvious by coming over to the scale by density and coming to the scale maximum, which is really the smallest size because we flipped it, and switching that down to like 0.1. You can see we have an even more aggressive blend from the largest grasses in the middle to the smallest grasses on the outside. So this is looking really good. It's looking pretty natural. You can go ahead and add a bunch of static meshes to your grass to give some more variation. I have a static mesh spawner here that I've saved that has just 3 individual grass meshes, exactly how I just used, as well as some little reed grass here, which is pretty cool. And I'll come back over to the scale by density and up the scale max back up to 0.5. Okay, so this is looking pretty good for me. We can always go ahead and test it by coming to our world settings and coming to the game override section. And if we've added the third person blueprint to our level, to our project rather, which you can always do by coming up here to the add button and come up here to add feature or content pack and coming and adding the third person content pack here. Once you've done that, you can go ahead and choose third person game mode on the right here, and then we can go ahead and hit play up here. We can go ahead and run around our level and see how our grass is feeling. So this is looking pretty good. I will want to make it denser in the future, but that's something I can add in my parameters. Now let's try to expand this grass to have it expand over our entire landscape. So what we're going to be doing is a multi-step process here. So we'll first open our PCG graph, and we want to go to the graph settings here. We click on that, and we want to make sure that we're using hierarchical generation. This is going to let us create a hierarchical grid size that's going to automatically spawn the grass as our character or our camera moves around. It's really efficient because we can spawn the grass and have it be pretty dense, but then only spawn it, only bring it up and actually render it when we're near it. And we can always modify that to get bigger or smaller, but it lets us have a lot more dense foliage in just the area where we are, either our camera or our character. This is a really efficient way to just do all of your foliage spawning. So make sure that this is checked on, and we'll come over to the beginning right here, right before I get the landscape data out, and we're gonna type in grid size. You can see it here under hierarchical generation. I'm going to choose that, and we're going to plug it in between here, between. And this is where we choose the grid size. So how close to our character do we actually spawn the grass? And I'm going to just drop it down to 3,200, but this is always something you can come in and change down the road. Okay, so that is good. We'll go ahead and hit save. So with the PCG graph selected, we're going to come down here to the instance area under graph instance, and here where it says is partitioned, we're going to go ahead and switch that on. And then we're going to go to the generation trigger and switch it to generate at runtime. Next, for you, I might have accidentally already set this up but for you, you'll probably have your grass will disappear at this point. That's because we need to go and here in the outliner, once we've added partitioned, we should see this world actor here. And if we expand it, you can see this will have your spawned PCG partitions inside of it. So we want to go ahead and select this. And then we're going to go and under the runtime generation, choose treat editor viewport as generation source. So now it will do that automatic cutting out of our grasses while our viewport moves around, not just when we're playing our game, which is important as we're editing here. So make sure that's selected. And if you don't see any updates here, you're going to want to come to your PCG here and hit refresh. And that will go ahead with the PCG graph selected here. Hitting refresh will just update, make sure that everything is running smoothly. So you should see some grass. You should see this PCG world actor, which is telling you that the partitioning is set up correctly. Now we can go ahead and expand this grass over our whole level without any worry of it, crashing on us or tanking our system. Let's go ahead to our graph. We will come and expand it, and I'll make it 2000 by 2000. You might not see a change right away, but that's because, if you remember, our grid size here is working. And I set it at a pretty low number because I wanted to make sure that depending on your computer, your system, it will make sure that it doesn't crash automatically. We can go here now and start expanding this number and testing it out, see that expand the grass even more. And if we go ahead and start moving, we can see that the grass appears further in the distance as we're moving. And if we go ahead and hit play, it goes and works pretty well with our character because, especially when we're at ground level here, it's going to look pretty good. I mean, I can't really tell the edges of the seam where the grass is, especially if I adjust the grass color to match the color of the landscape a little bit better. It would be a pretty seamless blend, and I wouldn't have to worry about, seeing the edge because it would just automatically adjust for me as I ran or as I went to different parts of the level. So this is a really efficient way to do really large landscapes, to do open worlds, and you'll see in a minute we can actually get some really dense grass without dropping our frame rate too much. Let's go ahead and hit escape to exit out of that. And now let's work on our grass parameters so that we can adjust them outside of the graph and start to creatively control this graph and reuse it and things like that. So we'll come back over to our PCG graph here. What I want to do here is start creating some parameters. And I have a few different areas of the graph that I'm going to add parameters to. And these parameters, just like material parameters, will let us change stuff about the graph from the outside of it. So we won't have to come into the graph for every time and adjust things on the nodes. Now that we have the general logic set up, we just need to play with numbers. So this is a great way to start doing that more creatively with your graph, just in the same way you would make a master material and you make a material instance, and then you do your actual tweaks in your viewport. Okay, so let's start at the beginning of the graph here and start to gradually move from left to right. The first thing I want to add a parameter to here is the create points grid node. If we use this little arrow underneath the grid points node, it will expand the inputs of the node, which you might not realize it has inputs by default, but it does. So if I expand it, we can go ahead and see all the inputs in the node that we would, be able to change with parameters. So if I click on the node, what I want to change here is the grid extents. The X and Y here are going to expand my grid that was spawning how far the seeds of the grass came out from that original starting grass seed. So this would be a great parameter to have because we could actually adjust how many grasses were spawning in each area and how far those clumps go. This will really give us a lot of creative control over the look of the grass. So I will come over to the parameter that I want to adjust, which is the grid extents, and I'll see here that I have an input here for grid extents. So let's make a parameter that plugs into it. I'm going to go here to the graph settings. You should see under the instance section some parameters. So I'll go ahead and hit the plus button and make a new parameter, and this one we will rename to be called grass seed distance, or whatever makes sense to you in terms of expanding the grass clumps. And by default, I'll look and see what this is. It's 500. So I'll come back here and make this 500 by default. And we can go ahead now and get this parameter somewhere in our graph by going and right clicking and typing its name. So grass, and we can see here graphs parameters. We get grass seed distance. We can go ahead and grab that. So I could plug this directly into the grid's extents, but what would be better in this case is, since the grid extents is actually a vector, I want to make a vector from this float. This is a single number. I want to control both the width and depth with it. So I'll right click and type in vector, and we'll choose this make vector attribute. And we can see here there's an X and Y, which is exactly what we want. So we'll plug this float into both. So now it'll just control both the width and depth. So now we can plug this into grid extents. Okay, now I can contract that. So now we have our first parameter. Let's go ahead and hit save and test if that came in the graph here. Underneath you'll find it in the graph instance section with my PCG graph selected. If I go ahead and expand the graph instance and then the instance again, and then under parameter overrides here, we can activate this grass distance as an option. And now I can expand this. Let's try 700. And you can see it expanded the grass clumping quite a bit, or I could contract it 100. You can see we're just getting one single grass, or we could expand it to 300. Will be a little bit sparser. Let's keep it at 500, but this works pretty well here. That's my first parameter. Let's go ahead and add a few more. The next thing I want to do is add a parameter for how dense the grass is by default. We have our expanding clumps, but what if I have big clumps, but I want to just control how many grass go inside that clump? But we can do that. If you remember, we made this attribute noise here, and we have this attribute filter. So we can expand the attribute filter, move this node out of the way here, and we can see we have our upper and lower bounds. And if we come over here and I start lowering that upper bounds, you can see it does exactly that. It kind of sparses the grass out a little bit. And if I go up again, it makes it denser. So this is a good parameter for us to make here. So I'll go ahead to the graph settings again, hit the plus button, make a new float parameter. We'll rename it to grass density. And we will make it 1 by default because we want to start it at the most dense. And now I can go ahead and type in grass density here, and we can plug that into the upper bound. We'll contract that. So that's that parameter made. Next, let's come to our distance node here. We'll expand that. The distance node, if you'll remember, is controlling the blending from the larger grasses in the middle down to the smaller grasses on the outside of the clumps. And so we could go ahead and add a parameter in here for maximum distance that we were, if you remember, we were adjusting this maximum distance to get our blend good between the values from the middle and the outside. So we could go ahead and go to graph settings, make a new one, and this one we will call grass age distance. Go ahead and get that. Grass age distance. We'll plug that into maximum distance, and we want to make sure we have that as 700 by default. It's important to set these defaults so that your graph doesn't get totally out of whack. Okay, that looks good. And the last one here we'll do for scale by density. This will be controlling the density exponent here. We didn't modify this much, but this is basically going to be a multiplier to this 1 to 0.5 range. So it'll make the effect more noticeable. So I'm going to go ahead and come to the graph settings and make a new parameter. This one we will call grass age multiplier. And we will go ahead and grab that. And we'll expand our scale by density here and plug it into the density exponent and contract that again. All right, now that's all our parameters made. We'll go ahead and save and close this graphs here. Oh, I think I forgot to set the age multiplier standard value here, which was 1, I believe. Yes, density exponent here was 1. So this is grass age multiplier is 1. Okay, we'll go ahead and save. And now we see exactly what we set up, but now we have the ability to come in here, increase the grass age distance, the seed distance, and we can go ahead and lower the density here if we want. We can use the age multiplier here to create more of a contrast. And so you can very easily start to adjust the look of your grass here very naturally. By adjusting our seed distance here, if I go to like 800, you'll see it'll start to create a lot more dense grass here. And if you're running into any kind of like frame rate issues here, once it simulates for me, it's running very smoothly. But if you needed to, you could always come back here to your graph, come to the grid extents and lower it a little bit down to 3200, hit save. And now if I go ahead and play, you can see we have this very dense, beautiful grass here, but it is, running pretty smoothly. And you can almost barely notice the grass in the distance getting spawned as I continue to run. And this would, this covers my whole landscape and it's very dense. So it's really great to make sure you have a good relationship between the density of your foliage and the grid size that you set up in your graph. So there you have it. That's how to set up very natural looking graphs. Some things you could look into to further develop this. If you're still feeling like you're not getting enough density of grass in your level here, you could always come back to the the surface sampler and up this points per square meter a little bit. You wouldn't need to update it a lot. You could even going up to 0.05 would give you this insanely dense field of grass here. So you don't have to, it's very sensitive because it's really that first point of grass and it's going to expand from there very quickly. So even just 0.02 would give you still really dense grass here. And then you could go into your parameters in your graph and continue to reuse them. Another option here for this grass here is that you could set this grass up to be a subgraph inside of a larger PCG graph. So if you want to use this again and drag it into another graph and have it spawn as part of that, all you would need to do is go ahead and disconnect the landscape here and plug the input in as instead, and disconnect the static mesh and plug it into output. And now this grass would be ready to just drag into any other graphs that you have and just spawn as part of that larger graph. All right, I hope you found this video helpful. If you did in some way, shoot me a thumbs up or a comment if you have any questions. And if you're interested in Aial Art Academy, you can find the link for that below this video. I will see you in the next one.